18 seconds.
Good evening, all. We welcome you to this International Alumni Workshop series on Valorising Life After Graduation, organized by Department of Chemical Engineering, St. Joseph College of Engineering, Chennai. I especially want to welcome our guest as well as our alumni, Mr. Shravan Muthukrishnan, Research Scholar at University of Technology, Australia, and our HODs, Dr. R. Bhaskaran Sir and Dr. N. Venkatesan Sir, my colleagues and participants from various institutions. To start with, life after college is beginning of a new chapter. There are plenty of opportunities and experience to be had which are unavailable in college. Many post-college students don't have their goal mapped out. You have an idea of what you would like to do in near future, whether it's starting a career or to continue their higher studies within a country or abroad. Making the transition of college student to young professional is harder for some, but if you are prepared for the kinds of responsibility you will face, it will get easier with time and experience. Now, our guest will explain about how to lead one's life after graduation. Now, I will hand over this session to our guest, Mr. Shravan Muthukrishnan.
Hi. First of all, thank you, Karthikeyan, for a great introduction. Actually, it took like 5 minutes of very nicely used set of words. So before I start my presentation, I would like to thank Vinod sir, who is not only my teacher and mentor, but also a great friend, and who has helped me through really well when I was in St. Joseph doing my bachelor's. And I would also like to say hi to Bhaskaran sir and Venkatesh sir. Hope they remember me. We had a great run in those 4 years from 2010 to 2014. So my presentation topic is, let me know if my voice is not audible, and I will just keep the mic close and make it sure it reaches to the ears where it's supposed to. So my presentation topic is Valorising Life After Graduation. And again, I'm Shravan Muthukrishnan, who is a research scholar at Swinburne University of Technology, Hawthorne, under Professor Jason Jain. So before I start my presentation, I would like to give a short introduction about myself. I am a master's in chemical engineering from NUS, and right after my master's, I joined as research associate at civil engineering department. I usually tell this as an achievement because civil engineering department is actually ranked second in the world after MIT, and they don't usually recruit a person who's a fresh master's and from a different discipline itself. So I was one of those few lucky students who got recruited in that department and did my research in construction 3D printing. So during that tenure, I bagged $300,000 plus of grant from different industrial partners, and few of them are listed here. One is OMIA, which is a industry based in Europe, and the second is Ministry of Drinking Water and Sanitation India, which is a government body, and all you know, a very famous Tata Group. So they all actually pitched in to my research, and we did research together to have some impact, social as well as economic wise, in the respective countries. During this project, I have two invention disclosures. One is titled Printable Concrete with Recycled Waste, and second one talks about how to use ground granulated blast furnace slag, which is a byproduct of steel manufacturing plant, and biochar to create sustainable concrete for 3D printing application. Last but not the least, I am a technical advisor to a spin-off which is called Biocrete. It's a startup funded by NUS itself, and I give some technical advice to them, which is their fresh set of students with high ambition to go forward. So I always believed you can't have two things together. You should always focus on one. Either you can be an entrepreneur or you can be a researcher. So from 2016 to 2019, I was doing more towards management-based research study, in which I wrote grant proposals and hired students to do research for me. At the end, of 2019, to be precise, September 2019, I chose to take the research lane where I joined Prof. J. Sanjayan, who is a professor at Swinburne University and a great policymaker in Concrete Institute, as well as the government body of Australia. To they provide standards for the building constructions and all. And I joined him as a PhD scholar. And right after joining, within 7 months, I published 3 papers. Title are shown in the presentation, and one is accepted but yet to be published, and 4 are under review. I'm very proud to say that in seven out of 8 papers published are first authored by me, and they are published in a Q1 journal, which has an impact factor of 2.3 to 7.2. Success is always a end to a movie, but there's a complete 2.5 hours of run before that, which I term it as failure. You rise from the failure, and how you rise from the failure actually makes you different from others. So in my case, I had a lot of failures, but I'm pointing only 4 of them, and I want to show like how I raised it from those ashes and made myself a bit successful at the end. So in class 12th, uh, I had an aggregate of 70.8 percentage, and usually most of you might know it. I mean, every state of India, this mark is below average. And when I wrote the last examination of my board, higher 12th standard board, I knew that I am not going to get good marks to get into any universities. So I tried hard and tried my best to get good rank in entrance examination. So we have a board examination as well as entrance examination for many universities. In my days, it was called as AIEEE and IIT JEE examinations, but now I guess it is called as JEE mains and intermediate, and they have other examinations for respective universities. So I secured AIR rank, which is All India rank of 3,327 for AIEEE, which is simultaneous to JEE mains, I guess, nowadays. And with that particular examination was written by more than 3 lakh people. So rank of 3,327 was supposed to be a good one. And after I entered St. Joseph's, the very first semester was 7.7 CGPA. I termed it as a failure because when I joined this university, I had a lot of enthusiasm and zeal to learn new things. I went to library after school hours and learned few stuff and tried to make questions or create doubts in the class such that students as well as faculty members have some attention on me. And when there was a good run going on, people thought that this child is gonna be a probable candidate for university rank, but I let them down when having a CGPA of 7.7 at the very first semester. So it not only embarrassed me, it actually shot me down to a very bottom level, and I had to get rise from that. And proudly, I could say that at the end of 8th semester, my CGPA rose to 9.17, and I am a university rank holder, which I'm not sure, it's 5th or 7th, but yeah, I'm a university rank holder. So after the graduation, when I joined NUS, as I said, after masters, I was recruited as research associate in civil engineering department. I had 23 failed grant proposals, and the very first proposal which I got was just for $40,000, and that was one of the most happiest moment in my life because it came after 10 failed grant proposals. And usually when you pitch in an area of civil engineering field and you have a master's in chemical engineering, the very first second when you introduce to the investors, like you are from chemical engineering, they right away look at their phone and try to pass those 3 minutes of pitching. So the 10 failed attempts before actually taught me which words not to use and how you can actually bag their attention. And that's how I got my first uh, research grant. But at the end, again, I'm proud to say that I was the youngest researcher to bag a total of $25,000, $250,000 Singapore dollars of research grant fund, and that was something good in Southeast Asia. The youngest in Southeast Asia, not in the world for sure. The last, but not the least, failure was my publication. No matter how management side you management oriented or inclined your research would be, but at the end of the day, they will ask like how many papers you have and what are the proofs that you have done research. So from 2016 to 2019, when construction 3D printing was a new field, and when I entered to research domain, and I had only, I mean, just the grants. I didn't have any publications, neither in conference or journal. So right after that, within 7 months, I managed to publish 8 first authored papers in Q1 journal, as mentioned before. So this way, I would like to say my success, which I've stated, are good, but I always focused on what my failures were and how I actually made sure like this failure doesn't happen. It's not prolonged to a certain stage in my life. I try to rise from it, and that's what I always say to other young people also. Please don't go down after you reach a failure. There is always a green light at the end. Please always look forward to that. So when you're in St. Joseph's, when I was in St. Joseph's, to be fact, uh, to be fair, I always had this three-step solution in which any problem I have, I always approach the faculty members, especially Venkatesh sir, Palniappan sir, Vinod sir, and Pratibha ma'am also sometimes. And I always seek their advice because these particular faculty members are more capable than just giving you lectures on the subjects and giving you university important questions in university examinations, and also do some argument on whether the mess food was good or not. They are much more capable than that. So they have also passed through the same era, same bachelors and all phases in their life which you are also going through. So they know much better, and your success mantra will be always be good if you try to build with the advice which they have given. So I did that uh, during my 4 years of bachelor's, and I always made sure that I also have something which is different from other students who are in the similar field. So as I said, I went to the library, and then I did some research. I'm not sure if St. Joseph's have this now also or not, but you can go to the library and I can download papers from the journal for free. Usually every e-copy of a journal will be around $35 to $40 uh, per paper, but this you can download for free from Swinburne Library, sorry, from St. Joseph Library. So better you do that. And your research interest, how to see like which professor is having your research interest or not. You can just go to the Google Scholar, type any professor's name and see how what are the papers they have published. For example, in my slide I have shown Bhaskaran sir's Google Scholar profile, in which you can see that almost, I mean, more than 450 people are citing his article, and you can see in what all areas he's working. So if that particular areas are your interest, then you can go and talk to him, make an appointment and talk to him. I'm sure they'll be more than happy to give you advice on that than telling how to make MS food better in future. Last but not the least, you should always have a good engagement and communication plan. In my case, right now, the three important forums or association I would say for my field is RILAM, Concrete Institute of Australia, and CIMIR and Concrete and Aggregate Australia. I have made sure that I'm a professional member in that. Most of them you get rejected, but you keep on sending an application. Try to improve your biodata, then send an application. Then they will make sure like you are a professional member in that forum. And then if you are a professional member in that forum, you get to meet and engage with a lot of people who are in the similar field and who will actually guide you through the success path. Then plus the communication, you definitely have some profiles in Facebook and Twitter, but also have a good working active profile in academic based social media like LinkedIn, ResearchGate, and academic.edu, where you can give your ideas. You don't have to publish paper or have some proof for that. You can just post your ideas in these three social medias. And sometimes I have seen few people who got recruited to professors' research team by just publishing the idea, like what they think can happen, just speculations, hypotheses. Just publish those. Then you never know. I mean, a dream professor or dream faculty member would come and accept your idea and want to work with you in future. So please do that. And the bottom are the 4 pictures which I took with district magistrate during my project in India. Then also the Tata owners. I mean, not owners. The chair, the CEO of Tata Sons. And then the last but picture is the one which I got awarded for the youngest researcher, which bagged 250,000 Singapore dollars as research grant. Yes, so in last 15-20 minutes I have been saying success mantra, but how to create a good success mantra apart from getting advice from teachers is that you also need to know 2 things, like what you want to do and what you have to do. What you have to do in my case was chemical engineering, because my father was a general manager in Indian Oil Corporation when I entered St. Joseph's, and I was sure that even if my grades are not good, that even if I don't have a good engagement or communication planned, because of his predefined network with his society, I would be able to get into some or the other position, or I would be placed into some of the other companies with from his uh, contacts. So that is what I had to do at that particular time. Then what I wanted to do is that civil engineering, because during my 6th or 7th grade, if I'm not wrong, I had this national science fair, and I was inclined towards building new stuff, societies or anything which was more in a very rough scale was inclined towards civil engineering. And last but sure, I mean, few movies like VIP also has triggered my interest, where Dhanush, I guess the actor name, has done good role and focusing like how civil engineer students are much better than any other guy. So these are the things which made me which actually listed civil engineering as what I wanted to do. And if you have a good linkage between what you want to do and what you have to do, if you are clear in that, that linkage will be your success mantra. For me, it was concrete technology. The concrete technology links civil engineering as well as chemical engineering, which is how I'm pursuing my PhD right now in concrete technology. So this brings to my topic, construction 3D printing. The thing is that I would like to give you a few context on why I chose this topic. Is that in certain national reports, it says that more than 150 million people, which is about 2% of the world population, are homeless, and 1.6 billion people, which is more than 20% of the world population, lack adequate housing. In places like Mali, also some places in rural area of India, uh, there are more than 80% of population which lack adequate housing. Now, when I talk about sanitation facilities in our own country, nearly half of the Indian population don't have toilets and they defecate in open. Why? I mean, why it is so? And in most of my presentation, I ask my audience to compare these 2 pictures, but right now I'll just go with the solution from my mouth itself. The left one is it's a construction method which was used. The picture which was taken from 1916, and the right one is the picture which is taken on 2020. So if you see, the construction method from 1916 to 2020 hasn't changed much. They still use the same formwork. They put the concrete in and remove the formwork and let the concrete dry and make buildings. You will be amazed to know that 50% of the total construction cost are those formwork. And if you want to have a customized design, if you have something curvilinear or have some really good shape, complex shape, then those formwork share the cost, the share of formwork on the construction cost will increase up to 90%. What if I say I come up with a construction technique where there are no formworks? And what if I say I increase the productivity of the construction by at least 5 times. So these are few problem areas which I want to attack, and in my research, I'm doing the same. To give an analogy, like what I said previously, I compare a construction process with baking a cake, in which uh, your mold, which actually holds the batter and gives the shape, is 700 rupees, whereas the batter, which actually is the thing which you eat, is just 100 rupees. And when your formwork is reusable, you get a cake for around 150 or 200 rupees in the market. What if I want to have a customized design for my cake, like a cake, like a picture downstairs? I guess it's from a movie Cars. And if I want something like that, I need to use a mold which is customized to me. That is why that particular cake is much higher than what you usually get in the market, which is rectangular or circle. So things we need is that we want a production rate or construction process with high productivity and formwork free. The material should be highly sustainable, because cement, for every 1 ton production of cement, you emit 1 ton equivalent carbon dioxide, which is greenhouse gas, and we all know what are the negative impacts of greenhouse gases in the society. And you should have a cost independent method of construction on design. That is, even if I go for a curve or any complex shape, my price should remain constant no matter what shape I look for constructing. And I would say labor free also, because if you want to go to certain areas which are remote enough where humans can't go and stand, uh, there the construction cost is majorly impacted by the transportation of human or transportation of labor to that particular point. So to reduce the complete construction cost or the overall construction cost, you need to have a method which is labor free also. So this is where construction 3D printing comes in. So as a proof of concept, I was given a project from Ministry of Drinking Water and Sanitation to replace or to build toilets in districts or villages in Tirupura, in Tamil Nadu, and Darbaga in Bihar. So I used construction 3D printing technique to replace all those not so good toilets to somewhat durable toilet with the money they gave. I guess it was $190 equivalent, which is 12,000 Indian rupees or 13,000 Indian rupees. And I had to build a toilet on that particular budget. And if you see the red colored section of the toilet, those are the recycled bricks, which I picked it up from the village itself. And the gray color one are geopolymers. They are not cement. They're cement free. They have waste products from coal-fired power plant, which Neyveli, I guess, in Tamil Nadu. I got fly ash from coal-fired power plant, and also rice husk ash. So in both the villages, the primary occupation was farming, paddy farming, and they threw rice husk, which is a byproduct of rice milling. They threw to water and contaminated the water resources. So I tried to extract those waste particles and turned into something which is useful for their own village by constructing toilet. So this particular project of mine piqued interest, and the same Ministry of Drinking Water and Sanitation gave me a invitation to discuss this with the Prime Minister office and how we could implement in a larger scale to every parts of India where it is required. And you can actually Google 3D printed toilet, and you can find the areas where we went and implemented this idea. Yes, so I'm just moving a little bit technical now. So I also want to prove how a chemical engineer is required in a civil engineering field. So this construction 3D printing can be categorized into major three sections. One is mixing, pumping, and extrusion. In pumping, usually we need the metal to be really low viscous, such that there is no blockage in the pumping line or the pipe. and the pumping line are, if you ask me, are really long. So you need to make sure that the viscosity remains low until it is extruded. And as an analogy, I would say the cement should have a consistency like of a batter, cake batter, which I've shown in the picture above. And right after extrusion, the material, because there is no foam work, the material should maintain its shape by its own, and it also should maintain the shape, should sustain the load from the subsequent layers, and should not have a major deformation, also should not collapse. So that particular property, I would say, should be like a toothpaste. Like after extrusion, after extruding a toothpaste on the brush, the toothpaste doesn't disperse, right? It just stays, it just maintains its shape. So your metal should also have that kind of consistency. So this all of this can be achieved if you really control the rheology of the material in those three stages. And no one better than chemical engineers can do that, because we have modules like fluid mechanics, and also we have learned how to control rheology and how to assess rheology in certain areas. Then it every cement particle, when it stiffens over time, it has certain chemical reactions happening. And if you choose a rate determining step uh, of those chemical reaction, if you control those chemical reactions, then it simultaneously controls the stiffening of the concrete inside the pump. So how to inhibit those reactions, how to control those reactions, again, I would say a chemical engineer would know better than a civil engineering guy. And third, but not the last, the mass transfer. When you flow stiff concrete or viscoelastic material through the pipeline, there will be some shear induced particle migration through the pipeline, and you have to make sure that those particular particle migration doesn't block the flow of material through the pipeline. So again, I'm saying, so uh, a field nowadays, any research is not a single department based research. It's a multicultural, interdepartment based research, and you need to know your area, how you can go and help the other department guys with your knowledge, and always be a big fish in a small pond, and you will get a lot of attention very easily, instead of just going to some processing line, I mean processing engineer or reactor engineer, which is almost everyone is doing after chemical engineering. So it's like a small fish in a big pond. So always I would say, rather be a big fish in a small pond than a small fish in a big pond. Now I would like to show a video which will actually give you an idea of what construction 3D printing is. And here it goes. Just 1 second. This house was built in 24 hours. How? Thanks to modern technology, Happy's Core 3D printing. Happy's Core, building the future today.
3D printing? I think I've heard about it. Well, but it was just so expensive. I don't think it's possible right now. But I've heard, yes, I've heard that you can make some stuff, some little stuff.
The house in 24 hours. No way. Pero hay tecnología mudada sobre la mustaqbal azim.
Y claro que gracias a este método podemos volver a construir las viviendas más baratas y más accesibles. Printed house? Why not? Why not? I think it's a good idea. Well, it should be the same, just like other houses.
والبناء عن طريق ال 3D سيفتح آفاق جديدة وفرص عظيمة للمستقبل.
Sounds interesting.
Construction 3D printing and its advantages have been known for a long time, but it didn't leave the facilities of closed factories. Existing printers are big and bulky, have a portal design, have height restrictions for printed buildings, as well as are difficult to transport and assemble on site. This is an expensive novelty which could never find a wide application in the construction industry. These printers print only separate walls and sections of buildings, and subsequent assembling is inevitable. The walls of this house were printed entirely on site.
This is the world's first actually printed house. With the advent of Appy's core technology, construction 3D printing opens a new round of evolution thanks to the innovative design of the printer. Appy's core technology consists of a mobile construction 3D printer and automatic mix and supply unit, which combine to make the construction printing process as much automated as possible and almost eliminate the human factor. This equipment is unique and has no analogs in the world today. Appy's core is compact dimensions, high printing speed, ease of transport, and maximum automation of the system. Commissioning on site takes no more than an hour. With so many advantages, the 3D printing technology easily accounted for competition, traditional methods of construction. The testing was successful, and the technology is ready for mass use. Our project has been implemented at the coldest time of the year. Application of the concrete mixture that is used as the ink is possible at temperatures from 5 degrees Celsius above zero. The equipment can operate at temperatures as low as minus 35 degrees Celsius. However, the problem was easily solved by installing the protective tent, which supported the required temperature. Time of printing amounted to 24 hours. Soon, using new materials such as geopolymer concrete, houses could be printed in both summer and winter. In the printing process, we used horizontal fiberglass reinforcements for the walls. The quality of the printed wall surface allows to perform final finishing immediately, which significantly reduces the cost of finishing works. The roof of the printed house, in accordance with the architectural project, is flat. Such a roof can effectively withstand high snow loads and durability requirements. Its cost is comparable with steep roofs, which are common for our country. Appy's core construction 3D printing technology adapted for different methods of printed walls thermal insulation. This project used loose dry insulating material on one part of the house and polyurethane filler composition on the other. Technology does not require fixtures and fills all voids in the space between the bearing wall and the outer concrete structure, avoids the formation of cold bridges. On the inside, the printed house is no different from a regular concrete house. It is also comfortable and reliable. The house interior includes a hall, a bathroom, a living room, and a compact functional kitchen with the most modern appliances. The house size is 38 square meters. Construction costs amounted to $10,134, which corresponds to approximately $275 per square meter. And this, in view of the shape complexity of the building. Prices include all works and materials for the construction of foundation, roof, exterior and interior finishing works, installation of heat insulation of walls, windows, floors, and ceilings. A regular square house made using materials of an average price category would cost about $223 per square meter. The use of Appy's core construction 3D printer allows to save up to 70% on erecting building boxes compared to traditional material and labor-intensive construction methods. The Appy's core company and its partners are confident that this house was the first step which convinced the world that 3D technology on the market today is a reality. 3D printers enter the global market and construction sites worldwide.
Yes, so Apiscore was one of our industrial partner, and if you try to grasp the word geopolymer concrete, that geopolymer concrete was actually delivered by my group back in NUS, and they tried it in Netherlands, where the temperature was as low as minus 50 during certain times. So the concrete was the how you invent or how you innovate in the concrete is very, very important in 3D printing application, which was very rightly mentioned in Apiscore video also. And they also mentioned about the cost of the house. Like it's just $10,000 for the whole building, which is equivalent to what is it, 5 lakhs or 6 lakhs rupees, Indian rupees for the whole building. You can't get that particular house even in for that cheap, even in outer outskirts of a city. So this is how economic this particular construction method is. Just because we have removed, there is no formwork. That formwork was removed, and we were able to save millions of dollars. In the next video, which is just for 1 minute, I would like to show like how complex shapes you can build using 3D printing, which is kind of not possible with traditional construction techniques. I mean, this particular areas are where I feel construction 3D printing will actually have a better role than other prefabrication or traditional construction. So just bear with me for another 1 minute. This video will show how you can build those complicated shapes. Yes. So I guess that's all from my side. And I would be more than happy to answer your questions if you have any. Thank you.
Good evening, sir. First question is from the participant named Murugapan, and he wants to know what are the various roles of chemical engineers in the field of civil engineering.
What are the various? Sorry, what are the various?
What are the various role of a chemical engineer in the field of civil engineering?
Oh, so there are many. I mean, not definitely in the structural side, but in the material side, there are many. If you even if so, like I said in the cake video, in the cake presentation, if you remember, I said if you have a mold which is reusable, then you can actually reduce the cost without investing in sophisticated machines for 3D printing. And chemical engineers, they have developed a lot of materials which can be reused, and those materials are all those formworks are also developed by recycled wastes, in way the circular economy is maintained, and also which reduces the cost of the formwork also. So there are a lot of areas where you can actually go and work in civil engineering field, but it all focuses on materials. Structural side, I feel there's less opportunity. I hope that answers the question, Murkapan.
Yeah, and the next question is, does additive manufacturing has any major impact on the environment?
It does a lot. It does a lot. So there's a study which says that during construction, there is almost 25% of the material just wasted. Like when you transport bricks from the manufacturing site to the construction site, and when you unload those bricks, almost 43% of the bricks get broken, and we don't take it into consideration because bricks are very cheap. When we talk about sustainability or environment, the way the brick is produced is very bad. I mean, the curing or during incineration, the carbon dioxide or the greenhouse gases which are emitted have negative impact on the environment. So all those wastages can be reduced with 3D printing because you're just precisely depositing material where it is required. You're not putting extra materials where it happens in the case of traditional concrete. So those precision in concrete deposition, you can reduce the material and you can reduce the negative impact on the environment. And secondly, as I said in my presentation also, you can replace cement with waste materials like fly ash, GGBS, clay, and so on. So in those way also you can save the environment by this method, by additive manufacturing method.
Yeah, and the next question is, what is meant by over extrusion in 3D printing?
Over extrusion.
Yeah.
This first time I'm hearing this word. Maybe that has to do something with when your material, as I said, when material has to pump through long pumping line, you keep the metal to be really flowable, and after extrusion the metal has to have a cohesiveness, it has to be stiff. But when the metal doesn't reach that stiffness which is required, your pumping pressure actually over extrudes the material from the nozzle, and it reduces the design quality of the structure. And if that is what you say over extrusion is, then I guess that is. But we call those things as reduction in design quality when you don't have a proper control of material rheology in every stages of printing.
Yeah, okay, so thank you for addressing all the questions.
Thank you.
Okay, thank you for your time, Mr. Shravan. I would like to express our sincere thanks to our guest, Mr. Shravan Muthukrishnan, for sharing his valuable idea in this international alumni workshop. I would also like to thank our beloved HODs for their moral support and guidance. I am very happy to express my vote of thanks to our staff members for their valuable suggestions and participants who have made this workshop a great success. Thank you. Thank you all.